Okay, guys, this is our lesson on two topics in our sequence and series unit. We're going to talk about sigma notation and infinite geometric series. So this right here is a sigma. This is a capital Greek letter. It's sort of like the Greek version of E. Have you ever seen the TV show Greek, which is about sororities or fraternities or something? They've got sigmas as their E's. Lowercase sigma is like this. So they have sigma and sigma where we have E, and you can kind of see the similarities. But Greek means sum. This is a symbol that you're going to see a lot in the more advanced classes you do. And this infinite geometric series topic that we're going to cover second is, it's kind of your first introduction into the infinite, which is what calculus is based on broadly. So it's kind of neat that you're going to add up infinity numbers today. It's a major step for you. So here's what sigma means. Sigma means sum. So the way you would evaluate an expression in sigma notation like this one is start at the bottom. In this case, what's called our index is I. It doesn't have to be I. It could be any letter. Our next example, it won't be I. But you start here with this value of I, and you plug it in. Okay, so when I plug 1 in, I get 2 times 1 squared, which is 2. Now, after you use 1, you plug in 2, and then you plug in 3, and you keep plugging in all of your whole numbers until you get to the top. So when I plug in 2, I get 2 times 2 squared. 2 squared is 4, 2 of those is 8. When I plug in 3, I get 2 times 3 squared, or 2 times 9, which is 18. And when I plug in 4, I get 2 times 16, or 32. And because the symbol sigma means sum, I add these together, and I get 60. I think I get 60. All right, so that's, sigma is, there are some advanced things you can do with sigma. One day you'll learn about a lot of different series. You'll see this symbol all over the place, but it's a pretty simple idea. You start at the bottom, you go till you get to the top, and you add them all together. So that's what sigma means. Now, one circumstance will be a little bit tougher is an example like this. What I hope you look at and see here is that this is kind of like y equals mx plus b, which means that this is going to be an arithmetic series. It's a series because we're summing it up, and it's arithmetic because we're going to increase by 3 every time. Now, once you recognize that it's an arithmetic series, here are your options. You can start at 4 and plug in 4 and get 12 minus 16 is negative 4. And then you can go up to 5 and plug that in. When you plug in 5, you get negative 1. And then we're going up by 3 every time, so then I'm going to add 2, and then I'm going to add 5. And I'm going to keep going on. You can do that for the over 200 terms in the list, or you use your arithmetic series formula. The series formula that we've been talking about, the one that Gauss is given credit for, says take the first number and the last number and add them up, and then multiply by half the number of terms. So the issue here is we don't know the last number. Well, if I were to plug in all of these terms all the way down the list, the term at the end of the row would be the number I got when I plugged in 276. So plug in 276, and you get 3 times 276 is 828. And then minus 16 is 812. I think that's correct, 812. Just make sure I'm nervous. 3 times 276 minus 16. 3 times 812, good. I hate to give you some incorrect numbers on a video. So what I've learned is that my last term is 812. Okay, I go from plugging in 4 to plugging in 276, and that's 812. So if I'm filling in, I'm looking for the sum. If I had started at 1 and gone from 1 to 276, then that would be 276 terms, and then my n would be 276. but I didn't start at 1, I started at 4. So this can be a little misleading. All the time I say, how many numbers are there between 4 and 276, or how many numbers are there in this series? And it's easy to say 272 because 276 minus 4, but since we included 4 and 276, there aren't really 272. It's like if I added up from 1 to 10. Okay, there are not 9 terms there, 10 minus 1. There are actually 10 terms because the 1 is included. So if you subtract the 2, add 1 back to it. So there are actually 273 terms in this list. So watch out for that little trick if this particular question comes up. So now to add up this sigma notation, 273 over 2 times negative 4 plus 812 would be 273 over 2 times negative 4 plus 812. Then all the terms in the series add up to 110292. And we have evaluated an arithmetic series that's just presented in another way. So I could have asked you that question a couple classes ago. I could have said, what's the sum of the series that starts at negative 4, goes to 812? Or I could have said, what's the sum of the series that starts at negative 4, goes up by 3, has 273 terms in it? It's just asked in a slightly different way. So there is your sigma notation crash course. Let's talk about infinite geometric series. Here's an example of a geometric series. S4 means add up the first 4 terms, and you can already see the first 4 terms. So we have 15, 17 and a half, 18 and 3/4. If you just add up the 4 terms that you can see. So let's add up 10 and 20 and 30 terms. Okay, so remember your series formula. It's the first term. I'm going to put my entire numerator in parentheses. First term times 1 minus my common ratio, which is 0.5, to the nth power, and since I'm adding up 10 terms, that would be to the 10th. Close those parentheses, and then close the entire numerator. Very common mistake is not to have your numerator and denominator in their own set of parentheses. Your denominator needs to be in parentheses 1 minus 0.5. The calculator knows order of operations. If you do divided by 1 minus 0.5, it's just going to take the number you had on top, divide it by 1, which won't change it, and then subtract 0.5 from it. So numerator and denominator in their own set of parentheses. So back to this question. What if I were to add up the first 10 terms of this series? I would get 19.980. I'm going to write them all out. 46875. You'll see why I'm writing them out in just a minute. So let's add up 20 terms. If you hit second enter, you get the same entry back. So if I'm going to add up 20 terms, the only difference is change that power from 10 to 20. And I get 19.49s 8093. 1, 2, 3, 4 nines, 80, 93. And you can probably see what's happening here. Let's add up 30 terms, just for good measure. Okay, so I get almost as many 9s as my calculator screen will hold. 1, 2, 3, 4, 5, 6, 7 9s, and then an 8. 1, 2, 3, 4, 5, 6, 7 9s, and then an 8. So what you can see here is that it doesn't appear like this sum is ever going to get over 20, no matter how many terms I add up. Just one more time. What if we did 50 terms? What will the calculator say? At that point, the calculator is going to say 20, but it's only saying 20 because with 8 decimal places on your calculator screen, 20 is closer than any number it could show you. Basically, what my answer is now is 19 with a bunch of 9s after it. So what's going on here is we would say that this series is converging to 20. All right, to converge means to never stop getting closer to 20, but also never quite reach 20. It's just like an asymptote on a graph. I could add up these terms forever and ever and ever and never get over 20. Kind of a make-believe real-world example, which kind of a oxymoron there, make-believe real world. But if you had a bucket, a 20-gallon bucket, and day one you walk into the room and fill it up with 10 gallons of water, and then day two you fill up half of the empty space, which would be 5, and then 2.5, and then 1.25, and so on. Theoretically, you could keep on adding water to that bucket and never overflow it. Of course, at some point, the drops of water get so small that you can't physically do that, but that's just a fantasy world example, since I don't have a good real world example. So what do you need to know about infinite geometric series? Number one, when do they converge? Not every infinite geometric series will converge. You know, if you add up 2 plus 4 plus 8 plus 16, that's what we call diverge. That adds up to infinity. In other words, there is no bucket that won't overflow. So when do they converge? Well, they converge if the number you're multiplying by every time is less than 1. In other words, if it's a fraction, you're filling up a fraction of the empty space, you will never overflow, even if that fraction is 99%. If you fill up 99% of the bucket and then the next day you fill up 99% of the remaining space, you still don't overflow the bucket. Thing number two that you need to know. I would like to not have to go through this progression to find that it adds up to 20. So this is the easiest formula yet. I call it S infinity, which means what does an infinite geometric series converge to? And it is T1 over 1 minus R. Okay, if you take that last series, T1 over 1 minus R would be 10 over 1 minus 0.5. 1 minus 0.5 is a half. 10 divided by a half is 20. Well, same thing as 10 multiplied by 2. So, for infinite geometric series, when does it converge? If you're multiplying by a fraction, whether that fraction is positive or negative. And what does it converge to? This formula. This formula does not apply if it's not a convergent. So make sure you don't apply this to a series like 2, 4, 8. Because it won't give you infinity, and it should give you infinity. So this formula is only good under those circumstances. Okay, so quick review. Sigma notation, it's just a way to express a series. If it's a small amount of numbers, you can start at the bottom and go to the top and add them up. If it's a larger series, you can use our old series formulas. And then infinite geometric. Sometimes if you're multiplying by a fraction, or if, in other words, if the numbers are getting smaller, then it will converge. It will never go over a certain amount. To figure out what that amount is, use this little formula. Okay? That is it for today. I will see you in class. I'm out.